Yeah, it's not. It's still not doing it. That's really too bad. Okay, so then type C would be y as a function of x and z, left surface to right surface, then projection into the xz plane. You get a region in the xz plane, and then your outside double integral would be for that outside region. All right, well, hopefully my GC file works. Okay, so I will. What I'll do is I'll make a video that you can watch of what should have been what you're seeing now. Oh, look at this. Here we go. Here's type B. It's graced us with its presence. So type B, front surface, or we said back surface to front surface, right? Does this work? No, that's not going to work. Okay, so type B would be back to front. Then we're going to project that thing into the YZ plane and do a double integral, either a type 1 or a type 2 double integral on that region of projection. All right, maybe we can get to see type C here. For it, maybe. But anyway, so there we go. Okay, so then type C, what is it? Left surface to right surface. That's all you can do is laugh, right? Left surface to right surface. Take the solid, project it to the xz plane, and that's your double integral. It will either be type 1 or type 2 in the xz plane. So let's quick get it out of the screen. So any questions on the general premise of these? So then how many possible combinations are there? How many, for rectangular coordinates, how many triple integrals can we possibly, how many orders of integration? 6, because you're going to have your type A, then your outside double integral is either going to be type 1 or 2. Then you're going to have type B. Your outside double integral for the region will be either type 1 or type 2. So there's 6 possible orders. Type A1, type A2. Type B1, B2, C1, C2. Okay. Anybody have a question? So let's see if my GC file will work, hopefully. Does my GC file come up? Yay, okay. All right, so I've got these points. The points are 2, 0, 1. 2, 0, 1. 0, 3, 0. 0, 0, 0, and 0, 0, 4. So those are 3 points, right? Or 4 points right there. And those 4 points define a tetrahedron. Okay? Those 4 points define a tetrahedron. And so first we want to sketch that tetrahedron. Okay, we want to sketch that. And so basically sketching it is connecting the dots, but we're going to need equations of the lines, all right? We're going to need equations of the lines. And the equations of the planes that create the surfaces. Okay, so can we write, let's see here. So let's just start with, so if I write on here, does it show up? This is 0, 0, 4. Is it showing up? Beautiful. And then 0, 3, 0. And this is our 2, 0, 1. And then the origin back here is 0, 0, 0. Okay, so can you write equations in each of the, so not equations in space, but just your old school, 7th, 8th grade equations of the lines. So you've got 2 in the xz plane, right? So here's xz and y. So you have 2 lines in the xz plane. You have 1 line in the yz plane. And then we have 1 space line, right? We have 1 space curve from here to here that's not in a coordinate plane. So can you write equations of those lines? Let's turn them on. It'll show up here. All right, so you got in the xz plane, you have this pink line here and the red line. And then you have the black line in the yz plane. And then you have the space curve, which is this blue line. So, let's pair up and divide up the task, okay? So, because we need to move, we can't spend 10 minutes writing the equations of these lines, okay? So, get a partner and figure these out quick. So you're writing them as if they were just what? If they were just rectangular coordinates, R2 lines. You have 2 in the xz plane, and you have 1 in the yz plane, and then this one is going to be a space curve, right? It's going to, because it cuts through space, it's going to need a parametric or a line, line function, an R3 line function that you learned this semester. The other stuff is, the other 3 lines are, they're not. They're like, pre-algebra, right? Write the equation of a line in the plane. It's just that this is xz plane and yz plane. Okay, so get a partner, work together. We're going to hammer this out in just a couple minutes. No, there's 3 lines that you're doing. You're doing this line in the xz plane, this line in the xz plane, purple, red, and the black line in the yz plane. Okay? I know it doesn't, the colors don't show up well. So we'll call it line. This is line 1. Roman numeral 1, Roman numeral 2, Roman numeral 3. Those are the 3 lines we're writing the equation of. Anyone got line number 1, Roman numeral 1? Kyle, what'd you come up with?
Z equals 3 halves x plus 4.
Z is 3 halves x plus 4. Negative 3 halves x. So we can check both points, right? If x is 0, we get 4. If x is 2, we get 1. It works. All right? Line number 2. This is an easier one, hopefully. What's that one? Z equals 1 half x. Positive. So yeah, as x increases, z increases. So we got positive. I did write that up there. So yeah, I think 1/2 x is right, because if x is 2, z is 1. That's right. So z equals 1/2 x. It's not showing up on my screen. Okay, last one, line number 3. Z equals 4 minus 4/3 y. Let's check it. If y is 0, z is 4. If y is 3, z is 0. That's right. Are they showing up? Not showing up. Okay, any questions on that so far? So now, what's that? It's not projecting. Oh, maybe it'll work. All right, so let's take a look. Ready? Maybe it'll work. Is it turning? So see, so here it is. Now look, this is what we just did. There it is. See? Now, what's it gonna look? So now, if I turn this thing so that you're looking this way at the XZ plane, what's it gonna look like? There's your projection in the XZ plane. Is that what you imagined?
Yeah.
Okay. See that? So when we turn this thing and look at the XZ plane, there it is. Oh, it worked. It's so awesome. All right, so